Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Julie Tomei. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at about 2 a.m. UT, if that's more your speed. York Universe production works in concert with our online and public viewing program run by our amazing observatory team, which runs between the exact same hours, 9 to 10 p.m. local Toronto time. To follow us or find updates, or perhaps navigate over to OPV at any other time, you can always see our website at yorku.ca/science/observatory and follow the links to OPV online public viewing, or you can find us on our YouTube channel with the Allan I. Carswell Observatory, every Monday. So let's go ahead and get started. We've had a little bit of a false start to the episode today, but we'll go ahead and open up and see what we can do today. The weather is currently promising, but we can't promise anything at the moment because the telescope is still closed. How is the skies over where you are, Julie?
They were a little fuzzy
A
when I
little
went out to
fuzzy.
pick up my daughter.
That sounds about right. I think one of the little fuzzes has coalesced into a cloud that is currently
Oh,
just sort of sitting atop the observatory domes. Just for our listeners, we did briefly have the telescope open. Um, if you have reasonably clear skies and you're in Ontario, you probably have a pretty good view of Jupiter tonight. We unfortunately just had to close due to that cloud. But if it moves, we will reopen and have live images. For now, though, we have some beautiful archival images, which are back up on the OPV YouTube, run by our amazing crew. So, false starts aside, maybe we go ahead and get started with our episode content for
sounds great.
today. We've got all kinds of things planned, things that go up, things that go down, things that go down very fast.
Mhm.
Um, I think you've got a very really good one to start us off, Julie. So why don't you go ahead and take it away?
All right. So we are going back to January 15th, 1969, with the launch of Soyuz 5. And Soyuz 5, once it was out in space, docked with Soyuz 4 while they were both in orbit. This was the first docking of two crewed spacecraft by any nation. It was the first transfer of crew from one space vehicle to another by any nation, and the only time a transfer was accomplished via a spacewalk. This was done 2 months prior to the United States Apollo 9 mission, where they performed the first internal crew transfer. It was piloted by Commander Boris Volynov and carried flight engineers Alexei Yelis, Yeliseyev and Yevgeny Krunov, and I hope I didn't butcher those Russian names too badly. And those last two were the crew that were going to be transferred to Soyuz 4 for reentry. They weren't up there just to switch crew and come back down. They also did scientific, technical, and medical biological research. They tested the spacecraft systems and design elements. Um, they docked the piloted spacecrafts and transferred the cosmonauts from one craft to the other. So Volynov helped his two colleagues put on their Yastreb, which translates to hawk, spacesuits in the Soyuz 5 orbital module, checked their life supports and comm systems, and then returned to the descent module and sealed the hatch behind him. Then that extra module was depressurized, the orbital module, so they could go out and uh, go join their fellow cosmonaut, Commander Vladimir Shatilov, in Soyuz 4. And he let them in, then went back um, into the smaller module, the descent module, repressurized so that they could take their spacesuits off and join him in the descent module. The two Soyuz crafts separated after 4 hours and 35 minutes together. And here's where things start to go awry. On reentry, the service module was supposed to separate after a retrofire, but on Soyuz 5, it didn't. And it was too late to abort. And so the spacecraft wound up in its most aerodynamically stable position, which was nose forward, which is not how you want your Soyuz to re-enter the atmosphere, because then it's only got a light metal entry hatch at the front to protect you. The gasket sealing the hatch began to burn, filling the compartment with dangerous fumes and smoke. The deceleration was pulling Volynov outwards against his harness rather than pushing him against the padded seat because the spacecraft wasn't oriented properly. Luckily, thermal and aerodynamic stresses on the combined spacecraft increased, and the struts between the descent and service modules either broke off or burned through before the hatch failed. And the descent module, once it was split from the orbital module, righted itself into the correct orientation before that service door failed, or that hatch failed. And the heat shield was then in the proper orientation for the rest of reentry. Now that's enough for one rough reentry, but that wasn't all that was going to happen. The parachute cables got partially tangled, and so the soft landing rockets failed. And so the landing was a hard impact, and some of Volonov's teeth broke on impact.
Oh, ouch.
Yeah. And he landed in the Ural Mountains, about 200 kilometers southwest of Kostane. And by my rough calculations, using like Google Maps and like the distance measurements on there, that's somewhere between 1,000 and 1,500 kilometers short of the target landing site. And it was minus 38 degrees Celsius, but at that range, Celsius and Fahrenheit are pretty close. It was cold.
Yeah, that's really cold.
Yeah. So he's been beat up. His teeth are broken. He's out in the middle of nowhere, and he knows it's going to be hours before rescue teams are going to reach him. So he abandoned the spacecraft. He walked several kilometers towards smoke he saw coming from a chimney, and he sheltered with some local folks till the the officials came and fetched him. Now, if I were him, when they tapped me and said, "Hey, want to go out on space again?" I'd be like, "No, thank you." But he did fly again 7 years later in Soyuz 21.
My gosh.
Yes.
That is a very extreme, like no wonder I say just like dramatic is the right word for that one. I mean, dangling out the escape hatch, basically,
Well, not dangling out the hatch, but like, you
hanging by
know,
your
dangling in your
seatbelt.
harness. Yeah, dangling by your seatbelt. Don't know if the hatch is going to make it. Smoke and fumes. Then then something happens and you're righted, and things you might breathe a sense of, or you might breathe a sigh of relief, but it wasn't over.
So how many of them actually came back in the mission? Was it only Volinov, or were they all in there?
So he was the only one that was in Soyuz 5 because the other two had transferred to Soyuz 4. So
Ah, so he was also by
he
himself,
was
right?
also alone.
So you're alone, alone on fire, hanging by your seatbelt with broken teeth and like 1,000 kilometers short of your target site at minus 38 degrees Celsius. Yeah,
Seriously, you
I
need to
have to
do
say
more of
I would
this.
be like, I'm okay, I think I'm done now.
Yeah.
Like
Like, no, thank
that's
you.
but he made it.
You made
Um
it.
and presumably went on to get his teeth fixed and go again. So um crazy.
Yeah.
That
It's
is
wild.
that I have to say that that would be that's a very sort of like Mission Impossible kind of reentry. Um or James Bond. Um
Right?
uh
Holding on to the outside of a spacecraft or whatever in one of the Mission
yeah.
Impossible movies.
Well, and I mean, good for him for getting back and um you know making it and going again. That's knowing what you're up against. And that is one of the things is people say, oh, space travel. And if you really think about it, space travel is fairly terrifying. It is extreme out there in space. It's minus 38 is cold, but it would have been far worse if, you're exposed to the depths
Yeah,
of outer space.
for sure.
And I would have to say this would be one person who actually truly would know what he's up against.
Oh, yeah. The amount of
Um,
contingency planning and
Yeah, and still
drills.
going with all that. And he was also, wasn't he I believe he was also considered to be the first Jewish person in space with that first mission.
Oh, I don't know. I didn't come across that. That's cool.
Um so yeah, very accomplished cosmonaut, astronaut, um and crazy mission.
Mm.
Um Well, speaking of things that crash down way really, really fast,
Uh-huh.
I can get us to our next one. So this was also, I'll just mention this 1969, the technology at that time um meant that there were safeties and backups, but it's not like what we think of today with like car airbags and stuff like that. The amount of safety that you actually had between you and the icy depths of outer space was a very, very small margin. And I think it's so cool what you mentioned that the temperature was minus 38 C. Coming back from space, that extreme temperature difference would not have helped the structure of his vehicle at all, because
Hmm.
he was in the coldness of space, burning up in the atmosphere, and then landing again at minus 38 C.
Oh, yeah.
So that's extreme. All right, so on a similar note, I suppose I could get super distracted talking about that one because it's really interesting. But I will continue on our journey. I'll go up a few years to the year 2000. January 17th in 2000, we have something passing away. In this case, it's the Mars Polar Lander was officially declared deceased on January 17th, 2000. So this is the day that they finally said the Mars Polar Lander, we are declaring you no more. It stopped communicating, and the final sort of attempt or the call was made on January 17th officially, that it was well and truly dead. So this is a Mars mission, as per the name, the Mars Polar Lander. It had a few different names, went through a few different iterations. It was also called Mars Surveyor 98, which I believe was aspirational because its launch date was 99. I guess delays changed the name or something. But it was a really interesting mission in a lot of different ways. The Mars Polar Lander passed away this day in history with the communication failure after landing. And this failure was very significant for a lot of reasons because in the 2000s, or this particular point in time, there had been some critical failures that had happened in space satellites and especially Martian space satellite exploration. And on review, independent experts were able to make the point and say, look, this failure of this craft was not um, it was not something that should have happened. Independent review showed that the support teams and the systems designed to weed out errors had been severely reduced. There had been extreme cost cutting measures that had taken place in NASA around the mission. Um, the director of the Space Policy Institute actually has a quote: "We're not spending enough to meet the goals." Um, and another quote, it was, "We went over the point where costs can be cut without putting the science at risk. Therefore, the science was at risk, and surely it failed." So this particular point in time, was when the Mars Climate Orbiter was also lost, and this was an elementary error confusing metric and imperial measurement, which you might have heard of. It's pretty darn famous.
Mm-hmm.
Imperial versus metric. But the NASA investigators concluded that the underlying problem was not the mistake. The actual error, confusing metric and imperial, came about because it was not detected in time by the overworked, undertrained technicians who were trying to do the job. And so the error was, in fact, a symptom of something that was happening at that particular time.
Mm-hmm.
And they did not learn from their lesson, and Mars Polar Lander suffered as well.
Yeah.
So the Polar Lander was a real, I suppose, a real kind of reset. It's like, look, you cannot cut costs on something as extreme as space travel and hope that it works out. Space is extraordinarily unforgiving, and landing on other planets is even more so. So
Mm-hmm.
uh, the uh, the polar lander was about 290 kilograms. It was a little robotic spacecraft lander, and it was going to study the soil and the climate near the south pole of Mars. And they expected that it would be able to land there and maybe look and examine some ice. But yeah, it did not. So it failed to reestablish communication with Earth. And again, the technical cause was pressure termination of the engine firing prior to the lander touching the surface, which is a fancy way to say it came down very, very fast. And it was going at a very high velocity when it encountered the red planet. These kinds of high velocity contacts are rightly called hard landings. This was a well and truly by the books hard landing when it should not have been. And it because it was such an interesting mission for studying, in particular, water on Mars. This one, although um, it did, you know, not succeed, the demos and the technology that had been used in the mission were actually able to be reused, or at least in part reused, for the Phoenix lander. So the Phoenix Mars lander 2001 basically was able to do this mission. So it eventually did succeed. Um, so Phoenix had 2001 plans, they had 2003 plans, they had 2007 plans, but they were basically able to save enough costs to make their quote unquote new mission be basically two small missions, because they had all of Phoenix, or they had all of, I should say, the Mars Polar Landers research and technology, and quite a lot of parts actually that they were able to use for their rocket. and they did succeed fabulously. So in this case, the actual ending did not go well. High velocity impacts tend not to be a winning proposal for any spacecraft. Lost on arrival was, I believe, the official status for the polar lander, and yeah, at least they were able to, in this particular case, make some lemonade from the lemons and use the technology for the Phoenix lander. I think it was 15 years on sort of plan. But the loss of that original craft and of course the climate orbiter as well, this actually threw a huge wrench into NASA's programs, um, and cost saving metrics, shall I say.
Mm-hmm.
Uh, it also blew out the schedule for Mars missions, meaning that it took a lot more time for those explorations to happen. So, I hope it's a lesson learned, but I suppose we shall see. Anyways, in this day in history, Mars polar lander passed away, and I hope we all remember not to overwork and undertrain our technicians.
Um, yes, I wish that were the case.
It's a lesson. Well, if some
It's
of
a
us learn,
super important lesson, and I'm sure some places are not overworking and undertraining people. I
well,
just kind of a cynic, and I'm not saying NASA specifically. I'm just kind of talking about the state of the world in general. Um,
well,
because
it is a critical error that a lot of places do make is you're trying to cut funds by
by cutting
cutting
staff,
valuable staff and training.
yeah,
And it's like, no, no, no. If you don't have the training and the staff, it is going to make everything orders of magnitude more difficult for the people there. And if you're also not going to give them way more time to do it,
yeah,
your mistakes will be made. And it's just you cannot have a high quality item um, on this kind of cheap. And
yeah.
um, at least with the more recent missions with Curiosity, they did properly invest in um, the landing technology and the craft.
Yeah. I get the saying is you can do it fast, you can do it cheap, you can do it well. Pick any of those two. You can't have all three.
Um, I think one would be. I mean, fast and well is also very, very hard. But
Fast
we'll
and well is
see.
expensive.
Yes, and I mean, I guess if you had enough people,
That's it, which gets
and that's
expensive.
it's the humans that make the difference.
Yeah, absolutely.
Um,
Got to take care of our humans.
I know, right? Uh, on that note, I hope everyone is staying warm and toasty. Um, it's Toronto cold weather here. It says like minus 12, but I don't believe it. It feels a lot colder than that.
Yeah, it's because of the wind.
Um, anyways, space hazards and lessons I hope are learned. Um, shall we go on and upwards and maybe backwards a few years?
Yeah, let's chat. We're actually going forward a few years. We're sticking with January 17th, but we're going to 2016.
2016,
Yeah. Uh,
basically yesterday.
yeah, basically, with the launch of Jason 3. Um, and usually I look up what these acronyms stand for, and I didn't do it today. I must be losing my touch. Anyways, Jason 3 is a satellite altimeter. It's a partnership of the European Organization for the Exploitation of Meteorological Satellites, or EUMETSAT, and the National Aeronautic and Space Administration, NASA. Um, and it is also an international cooperative mission between the National Oceanic and Atmospheric Administration, which you might know as the NOAA, partnered with the Centre National d'Études Spatiales, the CNES, which is the French space agency. The mission is to supply data for scientific, commercial, and practical applications to sea level rise, sea surface temperature, ocean temperature circulation, and climate change. It makes precise measurements related to global sea surface height. And the scientific goal is to produce global sea surface height measurements every 10 days to an accuracy of less than 4 centimeters. So its orbit takes it over each point in the ocean once every just under 10 days. The data are a critical factor in understanding the changes in Earth's climate brought on by global warming and as well as ocean circulation. The NOAA's National Weather Service uses the data to more accurately forecast things like cyclones, hurricanes. The data are used for marine and weather forecasts for public safety, commerce, and environmental purposes, research concerning global warming and its relation to the ocean, monitoring wind and waves on the high seas, hurricane intensity, ocean surface currents, El Nino and La Nina forecasts, water levels of lakes and rivers, and monitoring of environmental issues such as algae blooms and oil spills. It was launched via SpaceX Falcon 9 vehicle, and SpaceX attempted a controlled descent flight test and vertical landing of the rocket's first stage on their West Coast floating platform called Just Read the Instructions. The first stage did touch down smoothly on the ship, but a lockout on one of the 4 landing legs failed to latch. So the booster, though it did land properly, fell over and was destroyed. Womp womp.
Ah, yes. The famous get all the way there and then fall over.
Yes.
It's well, and that just goes to show as well, like how incredibly delicate this landing process is, right?
Yes.
And some, if you've had a chance to look up some of the landings on the floating platforms, they're pretty impressive.
Mm-hmm.
And but also so delicate. And
Yeah,
actually, oh yeah, go ahead.
this was early on in the testing of this process, and then they'd had a successful landing in their previous test, but this one did not work out.
Well, and I don't know if it's a coincidence, but I did go ahead and find the Jason name where it came from,
Mhm.
and it's not an acronym.
Well, there you go.
It's actually named after the ancient Greek mythological hero Jason, who
Of the
led
Argonauts
the
fame,
Argonauts on the
because the
ship.
sea and the
That
ship makes perfect sense.
yes, but as I recall, it was sort of a uh, a harried quest that he was on. It did not, it did not go entirely according to plan, so maybe that name was more appropriate than they thought.
Well, I mean, it sounds like the spacecraft's doing fine. It's just the booster that didn't land properly. So, um,
Yes, that's true. That's true. And that is the more important one because, of course, we absolutely need to be keeping an eye on the global warming situation, especially with the chaos going on with the whole polar vortex wobble and the extreme temperatures coming down.
yeah,
Yeah,
yeah, it's Spaceship Earth
absolutely
that where I'm
vital.
more worried about.
Yeah, yeah. So this spacecraft is doing good work for us. So it's
Yes,
a cooperation
hopefully,
between space and climate science.
yes, hopefully people will do good with the data. The data are
Yes,
there.
yes, they are. All right, so we're about halfway. So I think this is probably a good time to go ahead and do the reminder.
All
Everyone,
right.
this is your reminder that you are in fact listening to York Universe. York Universe. York Universe production that works in concert with our online public viewing, run by the Observatory team every Monday night from 9 to 10 p.m. local Toronto time. Tonight we are on YouTube per usual, and you are listening to Dr. Elena Hyde and Julie Tomei discussing things going down very, very fast, actually. So we've been talking about a lot of satellites and crafts which have had more or less success. And if you have any questions or comments, you can always email us at observe or go ahead and see our website, yorku.ca/science/observatory for all of our past episodes, as well as all of our other wonderful outreach events. So that's your short reminder, and as a little extra bit to that, I am going to just put the regular reminder here. The in-person tours at the Allan Carswell Observatory are back for 2024 every Wednesday that is not a holiday after sunset. So starting pretty early, right about this time of year. But we'll be getting later and later as the months progress. So we're currently starting at around 5:30 p.m. and you can find those free tickets on our website. All right, so just to go ahead and round off our This Week in Space and Astronomy history, I do have one more item, but it's a little bit of a cheat. So I wanted to put this in because it was something I actually didn't know about until I started looking up things for this episode. So the 19th of January 2024 actually hasn't happened yet, but maybe it will become This Week in Space and Astronomy history because it's actually the moment where the JAXA SLIM spacecraft is expected to land on the moon. This is pretty cool, actually, and we've been talking a lot. We're probably going to talk a little bit more about the moon in news items as well. I think we'll have time for it. Landing on the moon has been extremely popular recently, but we don't hear nearly enough about the Japan Aerospace Exploration Agency, or JAXA, and that's probably our own fault. Their lander is called SLIM, and it is a smart lander for investigating moon. So SLIM, they made the acronym work. That's only slightly tortured, so that's actually very, very good for astronomers. The SLIM is a small scale exploration lander, which is designed for pinpoint landings. So they're actually aiming for the exact opposite of everything we've been talking about today, which is a perfect landing that goes perfectly. They have a reduced size and weight, so that it's smaller than your average moon lander, and it's meant to sort of pinpoint land in exactly the place they want it to go to and investigate the moon's origin. It will test things like explore. It will test sort of technology. It will test low gravity environment behavior. So all kinds of fun stuff. So this is basically a study and to see if they can do it. They hope that they'll be able to use this pinpoint accurate technique to explore the moon and also eventually other planets as well. So the demonstration of the accurate, and this is what it's actually called, it is called the accurate lunar landing technique, which is really puts my hopes up actually. So literally in the name. And they want to demonstrate the technique in this small explorer, and they also want to look at studying the moon and potentially other places using a smaller craft. So this is what they're called, their lighter exploration system. So this is good because lighter craft, downsizing the system, basically you can have more of them. They are less expensive to launch. Putting things in space costs a lot of money. The heavier it is, the more money it costs. So, being able to put a small craft in that can do your science instead of a large one, or even two or three instead of a large one, downsizing your exploration system. So, this is pretty cool idea. Obviously, if you do this, if you have a smaller exploration system, you need to somehow, reinforce your instruments and make sure you have the exact right items for your specific location. So this has been delayed. It was actually hoping to be launched in 2021, which would actually put it in history, but it had a ride share mission. So it's so small, it was actually sharing a spot to be launched. It was actually successfully launched on the 6th of September 2023. So it was successfully launched. And it is in orbit around the moon. It entered orbit on the 25th of December 2023. So took a while, but it's in orbit successfully, going around the moon, and is expected to land in, if I look at my watch, if you're listening to this live, 4 days. So if you catch the recording, it might have already landed. And this precise pinpoint lunar landing is kind of cool because everyone talks about, oh, AI and machine learning and new technologies and things like that. But everyone knows well, I hope I hope everyone knows that AI is really just statistics. But one of the things you can do if you have the technology behind image recognition systems, and in particular, facial recognition systems, are very good at drawing precise locations. And they are actually using the same algorithms that are used commonly in facial ID to allow the craft to determine its current location based on data and soft land, which will be, again, not a hard landing. We don't want any high velocity impacts here. Soft land with a range of 100 meters or 330 feet. So in comparison, Apollo 11 was 20 kilometers. That was as good as it could get. So 20 kilometers or 20,000 meters. This is 100 meters accuracy is what they're hoping for. And it would in fact be more accurate than our on Earth landing mentioned earlier for Soyuz 5 as well. So I hope that they succeed, and it's a pretty cool little mission. Literally little and literally cold because it'll be on the moon. So looking forward to that one, and I just couldn't resist putting it in.
Couldn't resist pushing the definition of history.
Well, it is perhaps a new history moment, and I'm very excited to see what happens with this,
Oh yeah.
especially because there are some actually very good science uses for things like AI and ML data routines, and this is one of them. There are also a lot of bad uses, so that's another.
No, I'm glad you put it in. I'm always good for like ways of using AI that isn't stealing other people's art.
Exactly. There's no need for that. We have
Right?
we have plenty of really cool things we can do with this in space, you guys. In space. Anyways, so that's my not quite this week in astronomy and history, but it does lead in very nicely to our news section.
It
And we
does.
have two really, really cool news items for today.
Mhm.
Um, so I'm gonna let you go first because this sounds amazing.
All right. So in the 1980s, geophysicists discovered two continent sized blobs of unusual material deep near the center of the Earth, one blob beneath Africa and one beneath the Pacific Ocean. Um, the blobs are twice the size of the moon like each one, and likely composed of different proportions of elements than the surrounding mantle. They're formally known as the Large Low Velocity Provinces, or the LLVPs. And it was a mystery as to where they came from. Like, why would the Earth have formed this way? Now there's a new study led by Caltech researcher Chan Yuan that was published in Nature last November that proposes that they are what's left of Theia, the smaller planet that is thought to have crashed into Earth in the early days of the solar system. No trace of Theia has ever been found in the asteroid belt or in meteorites or any other place. And this study suggests that most of Theia became part of Earth, forming the LLVPs, and then the rest coalesced to become the moon. The LLVPs were discovered through seismology. In the 1980s, it became clear that in the deepest parts of the mantle, the seismic wave patterns are dominated by the signatures of two large structures near the Earth's core. And the structures contain an unusually high level of iron that makes them denser than their surroundings. And that causes seismic waves to slow as they enter the region, hence the name. So Yuan is a geophysicist, and he learned about the Theia hypothesis of the moon's formation at a symposium in 2019. And knowing that the moon is relatively rich in iron, he then had this idea, this, like, he called it a eureka moment, that the rest of the impactor could have formed the LLVPs. So he worked with a multidisciplinary team to model different scenarios for the chemical composition of Theia and the impact of Earth. And the simulations confirmed that the collision could have led to the formation of both the LLVPs and the moon. Some of Theia's mantle could have become incorporated with Earth's and ultimately clumped together. So why would the Theia material clump together instead of mixing with the rest of Earth's mantle and being all spread out? The simulations show that much of the energy, like under certain like starting conditions, much of the energy of the impact stays in the upper half of the mantle, and that leaves the lower mantle cooler. And so the lower mantle is not completely melted, so the clumps stay together and then slowly move more or less intact because they're so dense, sink down to the bottom of the mantle. The comparison in the article that I read talked about like lava lamps, and then when that whatever stuff in the lava lamps cools, it sometimes like sinks down to the bottom of the lava lamp when the lava lamp is off, which I thought was a good comparison. Had the collision delivered more energy, then the situation would have been different and more mixing would have happened, and perhaps the mantle of the Earth would have been uniform and a mix of both the Theia mantle and the original Earth mantle. But that does not appear to be what has happened.
That is really cool.
Isn't it?
And I mean, the idea of a collision forming the moon has been around for a while. But it's quite right that there's not been a huge amount of like really convincing evidence
Yeah.
that we can look at. And this, if true, would be literal remnants of that early body, Theia.
Yeah. Too bad it's like way down deep and we can't go get samples.
Yeah, journey to the center of the earth.
Yes.
Yeah, it is too hot down there. But it is really interesting as well from an electromagnetic standpoint, because these low velocity provinces, or blobs, as you say, I
Mhm.
mean, when you said lava lamp, that's exactly what I was thinking. And they contain a high level of iron,
Yeah.
and it really makes me wonder how is this affecting our magnetic field?
Oh, that's a fantastic question.
Is this helping to power our magnetic field? Is this why we have such an awesome magnetic field? I mean, obviously Mars doesn't have one because it's too cold, but we have a really good magnetic field. It's actually quite excellent and protects us from a huge amount of dangerous solar particles. Is this higher iron content structure rotating around inside our core helping to power that dynamo or making it more
Mm.
effective? Or like now I'm like, okay, well, I want to get out my old E&M textbooks and see what this looks like because I think this is just a magnetic field model waiting to happen. And if you have two blobs rotating, is this going to provide the mechanism for why our magnetic field has to flip? Wouldn't
Mm.
that be cool?
I think you just come up with two great questions for thesis
Yeah, if I
projects.
had more time, I
If you
would
needed
assign
another degree, no, you
if
just need to like pass it on to grad students.
yeah, if I had time and the money for a grad student, I would give it to them. And be like, "All right, here's your project. This sounds like an amazing. I'm sure someone's doing it already. But that is pretty cool.
So cool.
Anyways, excellent. Science is awesome, and they're still discovering so many things, even just about our own planet. It is just a great time to be, I don't know, interested in science, I suppose.
Mhm.
And it's also a very interesting time. It's also a very silly time, actually, because there is some ridiculousness going on that I think we have just enough time to cover.
Let's do it.
So last week, last week on York Universe, we talked about the Peregrine mission. Now, for those of you who don't know, the Peregrine mission one was fairly controversial. It was a lunar lander built by the Astrobotic Company. It was selected as part of NASA's commercial lunar payload services. So it was launched. It's a private company. They had their own ideas about what they wanted to do. They sold space on their craft to various individuals and people and programs, and they were going to land on the moon with their lander. Now, the rocket launch that actually sent them into space worked. They had a bit of a strange launch going forward. They actually had an agreement with the United Launch Alliance, which was I think we talked about last time. They I hadn't heard a lot about them, but actually, apparently they're fairly integral into this sort of new launching paradigm, if you will. And they launched aboard a Vulcan Centaur launch vehicle, which is a two-stage to orbit heavy lift launch vehicle. And this was going to be launched in 2021, but of course there were delays. They did actually launch on the 8th of January, 2024, which is very recent. So their launch was, just a few days ago, really, a few days and counting. And they were planning on going to the moon and doing some surface operations. But the real controversy came because they weren't just bringing experiments to the moon, and they weren't just bringing their lander to the moon. They had sold space to several people for cremated remains and DNA material. So some genetic material for preservation. And they were going to send it to the moon. And there were objections, but nobody got to really voice their or really say much because before anybody could say, "Hey, wait a minute," they had already launched. So we, um, as humans, did not get to have a conversation of is it okay to store our dead people on the moon? Never happened. They just launched. So this was a bit of a um, delayed controversy, if I say, but it swiftly failed this mission. So it sort of swiftly failed to orient itself. The thrusters were not aligning. I think, as I say, not aligning quite right. The launching worked perfectly. So the launch vehicle was a success. Um, the Peregrine, which was the a new launch vehicle, um, and it launched in kind of a cool new way. So successful launch, but very controversial private company spacecraft. And this is, now we have a chance to discuss it because the it's coming back. So the spacecraft, they had very, very little time to figure out what to do with it. Was fighting a fuel leak, so the actual lander, which was supposed to have obviously a somewhat soft land on the moon, was leaking fuel. It couldn't maintain communication, and a touchdown on the lunar surface was quickly realized was impossible. So they thought that they would try to get it close to lunar distance before they lose the ability to maintain its orienting position and lose its power. But actually, they have said, no, you're actually going to just crash it right back into Earth. So, unfortunately, all the folks who paid, I don't know if they get a refund for this, but the human remains are coming back to Earth via a deliberate descent into our own atmosphere. So they will burn up coming back, and
Oh
I don't
my.
know if you can be cremated twice, um, but yes, the carrying of human remains to the moon has been criticized by several groups. It's kind of on the same line of criticism as people who want to build things that are visible on the Earth-facing side of the moon.
Mm.
The famous, is it? Do we need to make some sort of rules before like Pepsi puts the logo on the moon or something? Because
Yes, please.
obviously we don't want that. Um, but yes, this was a very interesting mission in a lot of ways, and it did fail, and it is coming back to Earth. So the lander, um, the lander in particular, is had a fairly normal design, solar panels, thermal insulators, and some fuel for a controlled soft landing. It had a normal kind of propellant with 12 thrusters, and it just got up there and started leaking fuel, so they couldn't bring it back. Um, or they couldn't bring it to the moon, I should say. But I think choosing to come back to Earth rather than trying to just crash it on the moon from here or put it into lunar orbit is probably a much better, safer decision for all involved. Um, and it does have solar panels, so it will get a little bit of energy from that, but it's oriented such that it's once its fuel is not there to maintain its orientation to the sun, the solar panels won't be able to collect sunlight either, and it will be rapidly losing power. So yeah, so this is the story of the double cremated human remains that are on their way back to Earth, and the Astrobotic company lander that almost sent all kinds of things to the moon before anybody had a chance to think about it. So
That's
I
sketchy.
hope the space law folks are hard at work with this one. It is, as I say, it's a very strange one, but I'm kind of glad that it happened this way, if that makes sense.
Yeah. Is the controversy like we're sending people to the moon, like people's remains to the moon. We don't want to contaminate the moon, or is because like sending people's remains to space is already a thing.
Yes. I believe the controversy was sort of two-point, which was one is contamination of the moon.
Yeah.
Obviously, you would be contaminating the moon's surface. This is a lunar body. Do we have the right to just be putting our human stuff all over it? But also, the moon is to different people does mean different things, and
Hmm.
there were several Navajo Nation members, and in particular, the Navajo Nation president did actually put out a statement to NASA that said landing human remains on the moon would be considered desecration of a sacred space to them, and
Yeah, fair.
likely to other people as well. So there have
Yeah.
been
Enough
several.
sacred spaces have been desecrated as is.
Yes, and there have been several objections made, and the fact that they had to do this kind of as the mission was going, and it just kept right on going, does seem to indicate that there is a unique slot for space law to perhaps step in here.
Yeah, do it.
Because we now have the ability to do things that have never been done before, but that doesn't mean we shouldn't ask the question if maybe we should do them. Like, just because you can, um,
Are you
doesn't make
quoting the
it.
guy from Jurassic Park?
Maybe it's very quotable.
It is.
Jurassic Park is a very, very quotable movie. Anyways, I can't do the accent, but obviously, if you know Jurassic Park, you know what I'm talking about.
Yes.
Anyways, on that note, the failed Peregrine lander will be crashing into Earth by Thursday, January 18th. So this week is a very exciting one for space and all kinds of things.
Indeed.
All right, everyone. Thank you very much for listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Julie Tomei and myself, Dr. Elena Hyde. You can always connect with us on Twitter at the handle at York Universe, Instagram with at York U Observatory, and Facebook at Allan Carswell Obs. You can also check out our website for show notes, content, updates, and contact info, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, everyone, and have a good night.
Good night.